A legal player is one of the simplest types of game players. In each state, a legal player selects an action based solely on its legality, without consideration of the consequences whatsoever. Typically, the choice of action is consistent and selects the same action every time it finds itself in the same state. Using the basic subroutines provided in the GGP starter pack, building a legal player is simple. Here we see the entire implementation. Now, throughout this course, we use JavaScript for computer code, as I mentioned earlier. This is a compromise between Lisp and Java. Lisp is a powerful language, it's highly efficient, and it's easy to use in building players. However, it's not very widely known. Building programs in Java is slightly more difficult, but the language is familiar to more people these days. JavaScript has the flexibility of Lisp, and at the same time it's easily converted to Java. It can also be used directly to implement players either in web browsers or in standalone applications. Let's walk through this implementation. We start by setting up some global variables to maintain state while a match is in progress. There's a variable to hold the game rule set, a variable to hold the player's role in that game, a variable to hold a list of all the roles in the game, and a variable to hold the current state. And now properly we should create a data structure for each separate match, and we should attach these values to this data structure so that the player can actually play multiple matches at the same time. However, in this presentation we're striving for simplicity, and so we'll be treating these as global variables in what follows. Okay, next we define a handler for each type of message. The info handler does nothing at all and simply returns ready. The start event handler assigns values to the rule set and role variables based on the incoming start message. It initializes roles and the state variable, and it then returns ready. The play event handler takes a match identifier and a move as arguments. If the move is not nil, it uses nexts, find nexts, to compute the state resulting from the preceding state and the action supplied in the move. Once the player has the latest state, it uses legal x, find legal x, to compute a legal move. The stop event handler for our legal player does nothing, ignores the inputs, and simply returns done, as required by the GGP protocol. And like the stop message handler, the abort message handler for a player also does nothing, and it simply returns done. Okay, just to be clear on how this works, let's work through a short tic-tac-toe match. When a player is initialized, it sets up data structures to hold the game description, the role, roles, and the state. These are all initially empty. The player does not retain start clock and play clock since it does not need to do extensive computation for those limits are irrelevant. Okay, let's assume that the player receives a start message from the game manager, the sort shown here. Match identifier is M23. The player is told to be the white player. There are the usual axioms of tic-tac-toe. The start clock and play clock are both set to 10 seconds. On receipt of the message, the player code calls the start handler. This records the game description in the rule set variable, and the player's role in the role variable. It then computes roles from the game description and the initial state. Returned value is ready, which is then sent back to the game manager by the listener loop. Okay, now play begins after all the players have responded or after the start clock has expired, whichever comes first. Once the game manager is ready, it sends a suitable play message to all of the players. Here we see a request for the player to choose an action from match M23. Excuse me. The value nil signifies that this is the first step of the match. On receipt of this message, the player code invokes the play handler with the arguments passed to it by the game manager. Since the move argument is nil, no changes are made to the data structures at all. And using the state together with the role and the role description associated with this match, the player then computes the first legal move. In this case, mark 1-1, and it returns that as the answer. The game manager checks that the actions of all the players are legal. It simulates their effects and updates the state of the game, and then sends play messages to the players to solicit their next actions. In this case, the player will receive the message shown here, mark 1-1 from the white player, and no op, the only legal move for the black player. Again, the player invokes this play handler with the arguments passed to it by the game manager. This time the move is not nil, and so the player uses find nexts to compute the next state. There are two differences. There's now an X in cell 1-1, and control is switched from white to black. Using this state, the player then computes the first legal action in this state. Its only legal action, which is no op, and returns that as answer. Okay, this process then repeats until the end of the game. When the game's over, the player receives a message like the one shown here. Well, some players are able to make use of the information in a stop message. Our legal player simply ignores this information and returns done, terminating its activity on this match.